Hello everyone, welcome back to my channel. Today we are going to be covering on how to implement RAG in Python. So if you haven't watched my previous video about the theory of RAG, I request you to watch it. It contains the fundamentals and the concepts behind RAG, which we are going to use today in this video. So to implement RAG, we are going to be using two Python packages. The first one is called txtai and the second one is called LiteLLM. So these are the packages which are going to be used in this video. I am also installing this other package, which is the Wikipedia package. This is an optional package to get the data. If you have your own data, you don't need to install this package. This is just for demo purposes. So let's cover how to use each of the packages individually, and then we are going to implement the RAG system. So TextAI is the core part of the RAG. So txtai basically provides a vector database. So as I've said in the previous video, when you use RAG, you generally index the documents in a vector database. So a vector database converts text into vectors, which are basically lists of numbers. So the reason we do this is because uh, many times you want to find similar documents or you want to search for documents. So we cannot really do this by using keyword search. We need a more advanced version of search. So one way to do this is called vector search. Basically, it converts documents into vectors and we can compare these vectors to find similar documents. Here's an example to make you understand this concept. For example, we have three documents. For now, the documents are just one word, but of course, as we begin to use it further, we're going to um, vectorize larger documents. So for now, the words are apple, pizza, and app. Now, if you give these three words to a human who knows English, they'll easily identify that apple and pizza are similar because they're both edible food, while app is different from apple and pizza. However, if you give this to a computer, it will have trouble identifying the difference between apple, pizza, and app. To the computer, all three are simple strings. They're just lists of letters. So it may see the word apple and the word app and look at them, and then it sees that it has the common letters A, P, and P. So it may think that apple and app are pretty similar together. In reality, we know that apple and app are completely different. So in order to make the computer understand the semantics or the similarity between words, we can use something called an embedding model. So an embedding model takes apple and converts it into a list of numbers. It takes pizza and app and does the same thing. Now, when you compare the numbers of apple and pizza, you will find out that they are very similar because they're both food items. However, if you take app and compare that with apple or pizza, you will find that it's very different. This is because an app is a software. So once we have these vectors, we can basically organize them into an index. An index is basically a collection of vectors and it's designed to make sure that you can search for the vectors very easily. So to create a index with txtai, you first have to initialize an embeddings class and create an embeddings object. So you can just do this by importing embeddings. Then you take your sample data and load it into this index that you've made, and then you can search through the index. So for example, we have the search query food. Now what txtai will do is that it will also turn food into a list of numbers and it will compare this food with apple, pizza, and app. So when it's comparing, while looking at the numbers, it can see that apple and pizza are very similar to food, but app is not very similar to food. So apple and pizza will get a very high score while app will get a low score. So that's pretty much what TextAI does. Of course, there are a lot of other features that TextAI offers, but this is the main feature which powers RAG. Next, LiteLLM. So LiteLLM is actually a very simple library, but it is very useful and it will power the LLM side of things. So you have your data and you have your vector index. So you know what docs you need to power your RAG. However, you need to use the LLM. So to use the LLM, you have various LLM providers which offer an API. Some of them are OpenAI, Gemini, Anthropic, AWS, Bedrock, etc. So for example, you write an app that uses the OpenAI API. Now, what if you want to migrate to Gemini? You have to change the entire code base, and if you want to migrate again, you have to do the same thing. So LiteLLM provides a easy to use library so that you can write your code once and you can switch between different API providers without rewriting the entire code. So for example, currently I'm using uh, Google's Gemini 1.5 Flash. Say tomorrow I am switching to OpenAI's GPT-4o. Instead of rewriting my entire code, I can simply change the model and provide a different API key. That's it. Now the code will also work with OpenAI's API. So this is a very simple library, but it's also very convenient. So yeah, that's the basics of txtai and LiteLLM. Let's see how to use this to make a basic RAG program. So first you have to import the necessary packages. So I'm going to import OS for setting the environment variable, LiteLLM to power the LLM, txtai for the vector index, Wikipedia to get the sample documents, and I'm also importing Google Colab's user data module. This is completely optional. This is just to load my API key. So you can just paste your API key right here. So you just replace this user data.get function with your API key. I am not pasting my API key directly because I want it to be secure. So you can define this data within Google Colab and you can access it within your code. So you can separate your your information with your code. Okay, so I'm defining the API key using an environment variable, and I'm also defining the model which is going to be used. Then I'm going to fetch some data from Wikipedia. So this data is gonna be about these topics. It's gonna be about hummingbirds, the PageRank algorithm, Olympic Games, and Nobel Prizes. Okay, so once we have this data, we will initialize the embeddings object and index the data with it. Okay, nice. So now we'll take a sample query. For example, I'm gonna ask it what is the size of a hummingbird. This is going to be present within our documents because we have specifically requested a document with the topic of hummingbirds. So then I'm going to format the top documents. So for this, I'm going to use the search function, and then I'm going to search the top three documents. So this is the query we have already defined, and we have selected the top three documents, and we are going to format them. Finally, we are simply going to use the completion function, which is in the LiteLLM module, and we're going to set our model and the message. So I'm going to give a system prompt and ask it to respond only using the information in the context. So it will not hallucinate or generate information that is not verifiable. So after I call the LLM, I will just print the LLM's response. So let's just see what this. I'm also going to install Wikipedia. And now I'm going to run the program. So as you can see, the first time we execute this code, it will install a model from Hugging Face. This model will be used to embed the documents. So after you use it once, as long as you save everything, you don't have to install the model again. So once the model is installed, uh, the program will continue and we get the result right here. So this is the text which is generated by the LLM. Let's run it again to see what will happen. So you can see this time it didn't download the model, it just directly called the LLM. So yeah, let's test it with some more questions. So as you can see, once again, uh, it responded. This time is a different question. Now let's trick it by asking a question that is not present within the documents. So you can see it identified that the question that is being asked cannot be answered directly from the documents. So it just responded with I don't know, or this question cannot be answered from the given text. So this is helpful in cases where you want to trust the model and you don't want it to make stuff up. So you want to make sure that whatever is present in the documents gets answered and whatever does not, does not. Let's test with some other question. So you can see if you ask it a question that is sort of within the realms of the document but not directly within it, it will still refuse. So let's change the system prompt up a bit. So you can see it reasoned through the question and identified the correct answer. So yeah, that this is the basic RAG system that I have devised. Of course, there are many other approaches to doing this, and I look forward to covering more RAG approaches. If you want more videos like this, please like this video and comment as well. So yeah, please subscribe to my channel. Thank you.